Today's going to be the last day that we're going to spend talking about sequential games, I mean, just on their own. Next week, if you would read in Chapter 4 about simultaneous games, and we'll do that for a couple of weeks, and then we'll put the two sequential and simultaneous games together, and hopefully we'll get all that done kind of before the exam, which is the last week of term. Okay. Now, today's class, what I want to do is play a sequential game, again, kind of get you involved with it. This bargaining game that I talked about yesterday, where I'm going to start off with 10 things. And I decided to take a little risk here. I have up here 10 chocolate bars, and I also have here $10. Okay? So we're going to play this game for chocolate bars, and we're going to play it again for dollars. So what if you remember the nature of the game, we had the red players, and let's say the red players are kind of on this side of the room, and we have the blue players, and you guys be on that side of the room, and you guys in the middle, if you're a little kind of schizophrenic this morning, then just kind of choose one or the other, which one you're going to be, okay, red or blue. And the idea of this game is you have a pile of 10, and it's kind of this game is used to describe bargaining problems where, you know, people negotiate with one another, and if they don't negotiate, they got an opportunity to negotiate again, but by the time they come to negotiate again, the pie is sort of shrunk down. And then they can negotiate back and forth, and then if they decide to agree on something, fine, but if they don't, then the pie shrinks back down again. So it's kind of like, you know, by failing to come to agreement, the things that you could get are kind of disappearing, okay? And so we're going to play basically a 3-round kind of game. So the first round, the A players move first, and they have a pile of 10, okay? Now, what I'll do is I'll toss this coin to see whether we're going to play for coins first or chocolate bars. And heads we play for chocolate bars, and tails we play for coins, okay, if I can remember that. So heads for chocolate bars, tails for coins. But we won't decide that now. We'll decide it later. And what I'm trying to do is I'd like you to, I'm using this to motivate you to take your pen and paper, and as an A player, I want you to figure out what you're going to do. And a B player, I want to figure out what you're going to do. Now, figure out what you're going to do is one thing, but a strategy, remember, is figuring out what you would do in all the circumstances you find yourself in. Okay? So I want you to not only figure out what you're going to do and how to think about what you're going to do, but write down a strategy for yourself. So the first round, there's a pile of 10, either chocolate bars or dollars. And what you have to do as a red player is decide how much to keep for yourself and how much to offer the other person. Okay, so you got 10. So really the things you could do are 10 for me, none for you, 9 for me, 1 for you, 8 and 2, 7 and 3, 6 and 4, blah, blah, blah. Okay, just adding up to 10. Okay, so that's your first choice. And what about the blue players? Well, the blue players are sitting there, and they're looking over, they don't know what red players are going to play against. What are they going to do? They can either accept or reject. Okay, so what was your first name? Jason. Okay, so if Jason says to me, 10 and 0, you fail. Okay, no, that's not a consequence. It's just, 10 and 0. Nah, I don't think so. Okay, because even if I don't play the game, I get 0. But so the idea is he has to come up with a division, and I have to say accept or reject. Now, supposing that I say reject, okay, I might accept. The game's over. We split the chocolate bars or the money. Okay, but supposing I reject, then I get a chance to turn around and make a deal with him. I get to take the initiative saying, aha, we got a pile of stuff here. You know, I want to keep some. The only problem is the pile's only 6. Okay? So if we get to round 2, we only have $6, and we only have 6 chocolate bars, okay? So just take it at, say we get to stage 2. So the blue players are sitting here. So the first thing you got to figure out what you're going to do as a blue player is whether you're going to accept or reject, and then over there you got to figure out what you're actually going to offer. Okay, and the blue players over here, they don't know what they're going to do, but they can think about what they're going to do, because I mean, he's either going to say 10 or 0, 9 or 1, 8 or 2, you know. And let's say the first number is what the red player keeps, and the second number is what the blue player gets. Okay. You with me that? Okay, so far it's not too bad. Okay, so then the blue player is sitting there. Now there's 6. I can take the initiative, okay? And I can say, well, you can have none, and I'll have 6. You can have 1, and I'll have 5. You can have 2, and I'll have 4. Okay, 3 and 3, 4, and okay. So the blue player can propose a division of 6. Red player sitting over here thinking, oh, I wish I'd made a better offer at 10. With only 6 on the table, so but whatever, who knows. The red player gets to decide what they're going to do. Are they going to accept whatever the blue player offers? Okay, and basically it's like take it or leave it sort of thing. You accept it, but if you leave it, then the game goes on. And the game goes on to the next round, where, if you reject, the game goes on to the next round, and then we're down to $4, okay, and 4 chocolate bars. So 4 and 4. So it goes 10, 6, and 4. And then after that, well, the game will end, but it doesn't end quite yet because the red player's got another chance. Okay, they've got a smaller pie here because of all this toing and froing. The pie is shrinking. 4 for me, 0 for blue. 3 for me, 1 for blue. 2. I know adding is tough this time of the morning or afternoon, whatever it is. Okay, but we're trying to keep the things that add up to 10 or 4 or 6. It's not too bad. Okay, not too much math, just a little bit. You can use your fingers if you like. Maybe have one red hand and one blue hand, put some paint on them. But okay, so then you've got to make a proposal, and the blue player then has to accept or reject. If the blue player accepts, then we pay out at this round 3, and if they reject, then the game's over and nobody gets anything. Okay, you sort of fail to agree, come to agreement. There's neither of you get anything. Okay, got that idea? Okay, well now blue players, try and figure out what you're going to do, and we're now a little more sophisticated about what we're going to do because you've got to think about a strategy. Like, what are you going to do in all the circumstances you find yourself in? Same with the red players. What are you going to do in all the circumstances you find yourself in? Now, the first circumstance is round 1. The game might end there, but it might go on to round 2. Okay, so you got to figure out what you're going to do at round 2, which is not, you're going to either accept or reject something, and then if it gets to round 3, you've only got 4 to play with. You have to decide what you're going to do there. Okay, so at each situation, figure out what you're going to do. That's the strategy. Same with the blue players. Okay, you got round 1, you got round 2, round 3. Round 1, you got to decide to accept or reject. What are you going to accept or reject? And if you do reject, and it gets to round 2, what are you going to propose? And then if they reject, and it gets back to round 3, are you going to accept or reject whatever they're going to do? Okay. So just take 3 or 4 minutes. You can chat with your neighbor. But I would like you to try and write something down. And the idea, again, of writing it down is just, it kind of commits you a little bit to what you're going to do at the beginning. And remember, what I'll do is we'll flip a coin, and I'll just pick 2 players at random to play the first game, which could be for chocolate bars or money. $10 here, okay? Or 10 chocolate bars. Again, keep talk about it, because part of the process is reasoning, is kind of learning to think about this, and it's learning. You might not have great skills at the reasoning process right now, but probably by the end of the course you will have. Okay, so just play around in your head and try to figure out, what am I going to do as a red player? What am I going to do as a blue player? How you doing? Have you got something worked out?
Yeah.
What do you got?
So this is my strategy. I'd say I'll get 6, you get 4.
Okay.
4 is more than half of the next one.
Okay.
So that, I think that's pretty safe in saying that there's not much risk in them retreating it. Whereas if I say 7 and 3, then it's the same. There's no benefit for them to say accept the L.
Okay. And what's your first name?
Megan.
Megan. Oh, you Megan. Sorry, Megan. I've asked you about that about 3 times 7. It's crazy. It's like a lot of people I can't remember. Okay. So hang on to what you're doing. Okay, Megan. Okay. How you doing? You got something worked out?
Well, this is just what I would do. If I were red, I'd go 50-50. If I were blue, I'd accept it.
Okay. Now is that at every round?
No, not you want to do every.
Well, I mean, if you're thinking strategy, that's what you're kind of supposed to be thinking about, a little bit deeper than just what am I going to do. It's sort of what am I going to do in all the situations, like in round 1, what are you going to do? Round 2, you're going to do, if you get there.
If you get there.
Yeah, and then round 3, if I get there.
Right.
Okay,
Right.
so that's what I'm trying to get you to think about. Okay? Okay?
But that's all dependent on what
Exactly. That's what. Yes, part of the dependency is, well, gee, what do I think might happen out there if it does get to round? Let's say we get to the second round, you got to figure out. Well, they got 6 to divide up. They could keep 6 for themselves. You're gonna.
they can keep doing what they're doing, or they can maybe try to change it.
That's right. Well, you got to think about how you're going to think about a strategy in with all that kind of complex stuff going on. Okay.
She wants to think of every division pretty much possible that they could
Yeah.
throw your way.
Yeah. Okay. What's your name?
Pat.
Pat. Okay, Pat. How you guys doing over here? Yeah. Yeah.
They might accept it for 6-4, but they might agree to
Okay. Okay, that's good. So what's your name? Rachel. Okay, Rachel. Okay, cool. How are you guys doing?
We reckon if you were 70-30 and offer them the first choice of chocolate bar.
Now, which one? Are you guys? You're blue, remember? Okay.
Yeah. Oh, okay. For blue, you can't accept anything less than.
I like this lady. I'm going to hire her. Okay. What's your name? Kate. Okay. So we got Kate, Rachel, Megan, and Pat. I'll just do the feminine thing here. Okay, kind of walking around. I've only talked with a few people. I think it's really good, this kind of discussion you kind of have about their line of thinking. Now, I was talking with Pat up here, and Pat was, Pat, you want to put your hand up so that I wave? Okay. Pat was sort of saying, 50-50 this and something else, and he kind of had 2 little things written down on his piece of paper, and I said, well, that's what you're going to do, but is that what you're going to do at every round that you find yourself in? So the idea here is, you see, it's easy to say, what are you going to do? But it's a little deeper to say, what are you going to do in all the situations you find yourself in? That you got to think strategically. You've got to push yourself a little bit to think, well, what if, what if we get to round 3? Maybe we won't get to round 3, Like, it was about 3 years ago, there was a strike here at the university. And I have never been in a strike in my life. And I've never been in a strike at the university. And I've never been on a picket line, but I did, okay? And so it's like, frankly, I didn't think it would have any effect at all. And it gets kind of embarrassing when you're standing out there, with a bunch of other people with your pickets and stuff like that, and all the big guys are coming in, the TV cameras are there, and you feel, but, I mean, to me it was more a matter of principle rather than any outcome, because I don't think that it really had any effect on the outcome. I wish it did, but it didn't, okay? At least I don't think it did. But there's that idea, you're trying to decide, well, I'm going to do something, but other things might happen. I got to figure out what I'm going to do when those other things might happen too. Okay, so it was just, I mean, it takes a little effort. It's kind of tough, I know, but the effort level here is only 3 rounds rather than life, which is kind of complex. Okay, so let's toss the coin. What did I say? Heads? Are we doing money first or chocolate bars? Tails is money. Okay, so what do we got here? Well, I got a head. Okay, so we'll do chocolate bars first. Okay. Okay, so let's take we'll take Pat and Rachel. Okay, so Rachel, what did? Oh no, Pat, you're up. You're a red player. What? Pardon? You're red. So what are you doing first round? So that's 5 and 5. Okay. Now, Rachel, what are you going to do? Okay. Okay. So let me make sure I pay off this time. Okay. Now, okay, the other people don't. What are we doing here? Okay, just hang on a second. Okay. 10 chocolate bars. Made it. Okay. Okay, we're going to come back because we want to figure out what would they have done in the other rounds if they had got there. Okay. But now let's do it for money. Now we had it was Kate and Megan. So Megan, what were you going to do at round 1? 6 and 4. You were going to accept that, okay? 6 and 4. Oh, jeez, okay. You could have gone on a little farther. Would have had a little bit more or less left over, okay? 6. Accept it. Is that what you wrote down? Okay, I was going to try and catch her. If she hadn't actually written it down, I wasn't going to pay, okay? Because if she's not committed, I'm not committed, okay? Okay. Why did you offer 6 and 4? Okay, now let's take that a little. Okay, did you guys hear that in the back there at all? Okay, what Megan's reasoning was the next pot is 6. If she took half of that, she'd get 3. So I want to kind of, which she might do. So I want to guard against that by giving her 4, to give her inducement to do that rather than go to the next round. Because at least I get 6. Okay, and that's a little bit better than the 5 and 5 that Pat got, and Rachel accepted. Okay, okay. Now Pat, why were you thinking 5 and 5? Okay, so here Pat's reasoning, like, okay, you're starting off with 10 and to divide, and 5 and 5, well, I'm getting something, and if I go to the next round, I probably won't get 5 because there's only 6 in total. They're not going to offer me 5, so it's kind of like I want to avoid that, so I'm going to go for the 5 and 5 here. Okay. Okay, so Megan's saying, okay, I didn't want to go for 7 because then she's going to get 3 with me, and then she takes this next round. If you split 50-50, it gets 3. Okay. Now what I want to do is what happened in this game is typical of what happens in experiments. Notice Megan was thinking 1 round in advance, and Pat was thinking 1 round in advance. And you guys didn't really have to think too much in advance because the offers were acceptable in the first round, okay? So, Rachel, what would you have done if the offer had been 6 and 4? Would you have accepted?
Yeah, probably would have.
7 and 3? 3 for you, 7 for them?
Yeah,
2 for 8? You wouldn't have accepted. Okay, so what would you have done if you got to the second round? No, if they had offered 2 for 8, and then now it's your turn, and you say no. Okay, now but I've got 6 now. I'm going to make an offer. What are you going to do then? Did you write anything down? Exactly. Okay. You haven't anticipated. You hadn't worked it out. Okay. Now, see, part of the game theory thing is actually there's lots of possibilities, right? There could be 2 and 8, 1 and 9. You have to write everything down for every possibility. Well, in the theory, the idea is yes, you got to figure it out. But you sort of here, you got a cutoff strategy, kind of, right? It's like, okay, 2 and 8 or anything less. I'm not taking less than 2. So then you could figure out what am I going to do if I don't take less than 2. You don't have to do it for 1 or 0 because it's really probably going to be the same thing. Okay. Now Megan had I can't remember if it was Megan or Pat had introduced me. Well, what if they really get angry, in the next round because I offered them so little, and then, okay. Well, so what I want to do is I want you to think about the game even a little deeper because the theory predicts 7 and 3. Okay. And we want to see why the theory predicts 7 and 3. And one of the reasons it predicts 7 and 3, it's very much like what these guys were doing. They were looking forward, right? Okay, that's a huge step in the right direction. You only look forward one round, though. Okay, and you look forward one round and you try to figure out what was going to happen. And what you expected to happen was 3 and 3. But what you could have done was then put yourself in a blue's position and say, what could blue get out of this at the second round with 6? Okay. Now, blue, if they're doing the rational thing as well, they could be thinking, how much can I extract out of this 6 and 6? Okay. Well, even if you took your reasoning of the splitting it, well, they got 6 and 6. Can I keep 3 and 3? Well, I could go for 3 and 3 because the third round there's only 4. So even if that went 50-50, which it doesn't necessarily do, but it did, it's only 2 and 2. Okay. So they'd only get 2. So I got to make sure that they get. I could keep them down to 2 at the last. That kind of reasoning, it's one step ahead. Okay, it's kind of this. It's a little bit different logic because it's slightly different. But the idea of okay, I'm trying to figure out what's going to happen in the next round because I know that's going to affect what I can get now. But what's going to happen on the next round? The person over there is going to be going through the same, or should be going through the same reasoning. Well, what's going to happen in the subsequent round? Got that idea? Okay. Now that gets all really complicated when you're trying to start at the beginning of a game. And figuring out what's going to happen in the next round. This guy could do this, this guy could do that, and he's going to be thinking this could do this, and it gets really complicated. That's why we do the rollback reasoning. Go to the end. Work backwards. Okay? It's actually easier to figure out. Let's just pretend we've only got 4. Let's pretend we have 4. Jason, we got 4. Okay, let's do it. Forget about the beginning part. We got 4 chocolate bars. Okay. And we're going to pick a blue player over there. Kate, what's your name sitting next to Kate? Pardon? Daniel, okay. Now, notice already I've introduced Jason to Daniel, so they recognize one another. They're going to beat one another up because it's a male thing, it's a macho thing to do after if they don't split the chocolate bars, whatever, who knows. But pretend you don't know them. Okay, you've got 4 chocolate bars, and you've got to divide 4 chocolate bars. And if he doesn't accept, nobody gets anything. What do you think you do? 3 for you and 1 for him. Okay, Daniel, would you accept that? Why? Pardon? It's better than none, okay? But you could also get sort of pissed off. You could get angry. Say, no, I'm not, Now that's where you have to sort of figure out, is this guy the guy who likes chocolate bars and he'll take the 1? Or is he going to get really angry at me because I'm trying to take the whole heap, okay? Now, yesterday we did when I looked at the payoffs, that's why when you're reasoning, you have to try and figure out what the person's payoffs are. If they're only innocent chocolate bars, and more is better than less, he should accept 1. But if he's the kind of person that says, I like an equal split here, and if you don't give me an equal split, I'm going to get angry, then you do something different, okay? So that's all it's just think about what the other person's payoffs are, okay? 3 chocolate bars. Okay, Danny, can you catch? Whoops, okay. I was lucky to get it up there, they're showing it, okay? Anyhow, okay, so what I'm going to do now, we don't have a handout, so you can sort of sketch this little game tree down. What we're going to do is just analyze the game. I don't want to spend too long in this because I also want to talk about lock-in and hold-up concepts. But there is a, what was I going to say? I was going to say something deeply meaningful, but I can't think about it. Let's go reading, okay? Let's analyze the game, okay? Now, so get out your colored pens. And we start off, okay, when you're thinking about the game, and a lot of games are like this, okay? It's not a zero-sum game in the sense that everybody could benefit if they could get the big pie and agree to split it somehow, okay? But it might be, when we got people who split it, okay? But it turned out it wasn't it was going to be a prediction of a theory, but at least they split the pie. They got 10 and shared it out, because if they hadn't agreed in the first round, they would have gone into the second round, this pie would have been smaller. And that's like part of the problem with strikes. Strikes can go on a long time. And the longer they go on, the more costly it is for people to carry on these strikes, and the benefits. You had all these benefits you thought were going to be there, and they just keep shrinking because people are incurring all these costs in these strikes. And so you're trying to figure out, well, this kind of bargaining stuff that we're talking about is really the theory that's used to analyze, how do strikes go, how do labor negotiations go, how do wage management negotiations go. So now here we go. We have we start off with the red player moving first. Now, because the red player can do so many things, I've put a little band around their actions here like that. Like if you want to go to the detail, you'd say, okay, look at, what can the red player do? They can keep 10 for themselves and 0 for the other guy, 9 and 1, 8 and 2, 7 and 3, blah, 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 okay? And, but that kind of gets a lot to write down, right? So what we could do instead, we could just put one little line and a little band that tells us, you don't have to worry about algebra here. It's just more, there's a bunch of things you could do, and you want to keep track, so through the symbols there, we could say, well, let's let x1 be the amount that the red guy offers the blue player, okay? So it's really the blue player, what the division the blue player is going to get, and then you get the balance left. So I'll offer you 2. I'll offer you 3. I'll offer you 4, and I'll keep the rest, okay? So that's what this little symbol here is. Then the blue player comes into the game. They have a decision. They can accept, and the game ends with the same payoff. Well, this is really the same outcome, okay? The same outcomes here as what the division of the pie was down here. And if they reject, then they can make some offers that are between 6 and 0, x2 for the red player. Could be 0, could be 1, could be 2, could be 3, could be 4, all the way up. And then the red player gets to accept or reject. If they accept, they divide. Here's the amount of money they get split, the 6, and here's the split, and this corresponds to that division that was proposed by the blue player. So that this outcome up here, which we're thinking of as the payoff, okay, because it's just in dollars or chocolate bars, and this action down here are really described by the same 2 numbers. It's a way of dividing the pie up, okay? And then finally, we come to the end of the game where there's only 4 chocolate bars, and the blue player can either accept the red player's division, or if he rejects it, everybody gets nothing. Okay, so that's just the nature of the game. Okay, so I'm going to put this up on another slide here because I have some other stuff I want to add to it. Okay, you got the idea? Now, basically, what you're sort of thinking about is there's a sequence of rounds, and instead of just looking 1 round in advance, you want to look a couple of rounds in advance. And the easiest way to do that is to start at the end of the game. So let's start at the end of the game, where we're trying to figure out what's the division here. And this little section, if you put a section on that, so forget about this bit here totally. This little section is called an ultimatum game. It's a bargaining game, and it's a take it or leave it offer. There's no future. It's like, it was what Jason was doing, 4 chocolate bars. You make your offer, it takes it or leave it, the game's over, and nobody gets anything, or you make the division. Okay, it's not like there's any sort of future, which is, they go out in the corridor after and this sort of thing, or something like that, or they have a chat or whatever. And that's the problem with a lot of bargaining games is they actually do go on, even though you'd think they might be closed off. Anybody in a relationship knows these things. Okay, you want to go to the movies tonight? Yeah, let's go to the movies. Should we go to an action adventure? Oh yeah, sure. Okay. I wanted to go see that other one. Something like that. It's like always some future that comes back and haunts you. Then you step back and you think, okay, I didn't really want to go to the action adventure that much if it was going to cost me this much in the future. So, but here our little games are just, I have experience in these things, okay? But I have been getting into Bollywood movies, by the way, which most women do like as well. They're really fun. Yeah. If you haven't seen Doom 2, you must see it. DHOOM 2, absolutely fantastic. Stunning action adventure, all kinds of cool music, great dancing, great music. You got to have something in life, okay? Just I can't be an economist all the time. Okay. So what I do here is we just analyze this part of the game. Okay. So we've got 4 and 0, 3 and 1, 2 and 2, 1 and 3. The possibilities are right here, and what we're trying to do is figure out from the red player's standpoint, what will the blue player accept? Well, clearly they accept that he gave him the whole pie. I mean, clearly in the sense that if their preferences are just for their chocolate bars or their money, but what do you get if you offer them a whole pie? You get nothing. So part of the game is I'm an intelligent player, I'm the red player, I'm trying to get the best I can, but if I go for the whole bundle of wax, 4 and 0, then, I mean, if I was the blue player, I'd be taking it to the, you know, there's no way I'm giving you everything and just taking it myself. Now, if you make that assumption, okay, that you've got it, then this is an assumption. It might be if you take 4 and 0, the blue player, 0 either way, who cares? I'll accept it, okay? Now, sometimes in theory, you do make that assumption that a blue player will, or the other player will accept the very limiting amount, okay? But here, let's just assume that you've got to give them at least enough at this stage, at least something that's better than what they get at that stage. So 1 is better than 0, 2 is better than 0, 3 is better than 0, 4 is better than 0 for the blue guys. All of those, you could give them all of those possibilities. Out of those possibilities, what's best for you? 3 and 1. Okay? So the idea is that you're trying to figure out, okay, I'm looking forward. I'm not imagining a 50-50 split. Jason didn't do that. Okay, he didn't say 2 and, you know, it's just, you know, what we're thinking of is if I take it to the next, if I take 4, he's probably going to reject that. But as the other possibilities, I don't have to go for 50. At 50, I can go for 3 and 1. And I should expect him to accept that. Okay, so let's just put these 3 and 1 as our prediction for what the outcome of the ultimatum game will be at the end. Okay? And now it's a little bit easier to think about it right at the end, right? We've got 4 chocolate bars. How are you going to divide it up? What can you get? And if it's 2 self-interested agents, you could get 3. The other guy could have 1, and he should accept that. Okay? If he's one of these people that likes equality and is going to anger at you, then you're playing the wrong game, and then you'd expect 2 and 2 or something like that. Okay? But with these payoffs and players, this is what we expect. So now we go back and we'd say, what about at this stage down here? Well, let's just cover this guy up over here. We got the future figured out. We look forward and we figure out the future is going to be 3 and 1. 3 red, 3 for red, 1 for blue. And so back at this stage down here, we have to look at the possible divisions of 6 by the blue player. The blue player is trying to figure out what's going to happen if red accepts. Well, that's great. You know, we'll just walk away. I can take 6 myself and leave him with nothing if he'd accept that. But he can get 3 and 1. So I have to give him at least 3, and by our assumption, we have to give him 1 more. Okay, so that's 4 and 2. Let me just put that in. Okay, you got the 4 and 2 idea? Why do I have to give him 4 and 2? Propose 4 and 2? Well, because if I try to take any more for myself as a blue, if I try to take 3 and 3, then he's going to carry it on to the next round. Okay? And in the next round, he can get 3 himself. And we've sort of said, if he can get 3 himself, he'll always go to the next round. So I've got to give him something more. I've got to give him 4 because he can get 3 in the next round. Okay? Then we go back to the first bit. And you work this out. You sort of sit here and think, what's going to happen in the first round? Well, we've got the future figured out. The future's collapsed to, well, if we did get to the second round, the blue player is going to get 2, the red player is going to get 4. There's a total division of 6. And then you might ask, well, why would you accept 4 and 2? And that's where you'd say, well, because the 4 and 2 is the solution of another thing which we predicted is if we got to the third round out here, the last ultimatum game, then we'd expect 3 and 1, and that's why we have to have a 4 and 2 here, and this is why we have to have a 7 and 3 here. Okay, we would expect 7 to come from the reds, 3 to go to the blue, and they would accept. Now we got a 5 and 5 and 6, 4, but nobody really, none of the reds extracted the full amount they could extract. Okay, Megan, are you with me on that? Do you see the reasoning? I mean, it's complicated because it's a little bit easier to think, I got to look ahead 1 step at least, and then what's going to happen 1 step ahead? Well, you were saying 50-50, 3 and 3, which is fine. You know, then you work backwards from there. Here I'm saying you could be a little more sophisticated. You're not going to get 3 and 3 in the second round. You're going to get 4 and 2 in the second round. Why were you going to get 4 and 2 in the second round? Because you expect to get 3 and 1 in the last round. Okay, that's the kind of analysis I want to be able to do. Now, if you go into the past exam questions, I think it was last year, I can't remember. I have a little. I have a couple of little games that are like this. They're negotiation games, and one of them is between a little old lady and a kid who's going to cut his grass, and they're trying to make an agreement about how much he's going to work. How much he's going to get paid to work to cut the grass. But she wants to cut right away, and he doesn't want to do it right away. Okay. And then we got another one. We got a farmer, and we got some people who are going to harvest their crops. And the idea is they got to come to a bargain about the wage. But every day, every week that goes by, the crop is getting smaller. It's getting rotten. The rains are coming and stuff. It's shrinking. Okay. So this so there's two questions in those past exams, which I'd urge you to try and do. Okay. Just kind of go back. It uses the same logic. Okay. Now there is another solution to this. And the other solution says, okay, Jason, when Jason was offering Daniel, you said 3 and 1, because if you don't offer him 1, he could take, if you say 4 and 0, he could take it to the next round and punish you by getting the 0 and 0, okay? Well, another assumption which you could make, and it's just as good as this one, is that a person will always accept that kind of limit offer. So you could have kept 4. If your theory works that way, it's just an assumption. It says, okay, I can keep 4 for myself and give him 0. Why would he accept 0? Well, I'm just going to assume he'd accept it because it's at least as good as what he could get anyhow. Okay. I think the better assumption to usually make is you've got to give a person a little bit to prevent him from going on the next round. But if on an exam I'm asking that question, you could answer it either way. Now, let's just sort of think in our heads without drawing anything down. We sort of think, what if you did 4 and 0? Okay. That means that you're going to get 4, he's going to get 0. So if we go down to round 6, what does the blue player have to do? What's he going to have to do? Well, how much has he got to guarantee the red player? The red player can get 4 in the last round, so he's got to give him at least 4 at round 2, right? But we said he will accept 4. Right? He'll accept. If the two things are equal, he'll accept it. So the blue player's got to give the red player 4 because he knows the red player can get 4 in the last round. That means the blue player can only keep 2 for himself. Okay. And then we could go back to the first round. It would be 8 and 2, because of the first round, you would know that you can keep 8 and give the other guy 2, because in the second round the most he can get is 2, because the most he has to give you 4, because that's what you can get, or the red player can get in the last round. Okay. Now, I did that quickly because I didn't want to spend too much time on it, but you could work your theory would predict either 8 and 2 or 7 and 3. Okay. Okay. Let's leave this. Silence is overwhelming. Okay. I know I'm pushing it a little bit hard, but it's really only 3 rounds. It's a bargaining problem, and I don't know whether in the course we're going to get a chance to get to the bargaining chapter in Dixit and Skeeth. I'm not sure we'll be able to come back to it. I think it's about chapter 15 or chapter 17. Very interesting ideas there about bargaining. Okay, and it's all really built around these stylized little kind of games about looking forward, trying to figure out what the other person's going to accept or not accept, and work out your own solutions. Okay. Now, theory and evidence, very quickly. There, you got that? Good. Let's go to the next one. You didn't get it, did you? Okay. I didn't hear any laughter at all. You can read about that on the webpage. It's a little discussion about some empirical evidence about why people do just what Pat did and Megan did in this class here. Like in an experiment, they're trying to figure stuff out, they make expectations, and they don't do what the theory predicts, but it doesn't mean they're not trying to figure out what's going on. And so that little section of Martin Osborne's book just describes these guys who are trying to figure out what is it people do in these games, okay? How are they thinking? Because it's not quite what the theory says. Now, a really interesting thing is that they were able to rationalize this kind of behavior by thinking not so much, it was more like, what if the other person isn't quite as rational as I think they should be, okay? And then it makes sense to kind of go on in these little games a little bit. So, okay, let's have a look at the concept of lock-in. Now, essentially, I put in 2 chapters from Varian and Shapiro's book, Information Rules. Chapter 5, I think, is the key one. If you get interested in this, read through Chapter 6 as well. I think anybody who works in, or thinking of working in, with the Internet, networks, databases, software, computers, video, multimedia stuff, read this, okay? Because it's really fun and it's very interesting. And there's a phenomena called lock-in that we want to describe. And basically, the simple idea is this. The choices you make today hem in the choices you can make in the future. Okay? So the things you do today will kind of constrain or affect the possibilities you have in the future. Now, that's one thing. And then the other thing is you're going to be dealing with other people who are going to take advantage of that, and that's called hold-up. Okay? Because they're going to take advantage that you're kind of locked in. So I was trying to think of some simple examples of the lock-in phenomena, and it's all built around the idea of switching costs. So let's take your selection of courses. Okay. So when was the due date for the enrolling or disenrolling a course? 2 weeks ago. 2 weeks in, and what's the penalty if you want to change after that? I mean, if you want to drop a course, if you want to enroll in a new course, can you? Do you have to pay money? Theoretically, you should, but you don't. Okay. $200. More than one. $100. I mean, so if you wanted to cancel it, got a 223 and join in some other course, they'd charge you $100. And if you wanted to do two of them, it would be $200. And you don't get your fees back as well. I mean, you got to pay the fees as well as so not only not a rebate, but they give you a penalty. Okay, so a fair bit of money there. And so the idea is you're sitting there at the beginning of the term, and you're trying to think, I don't know, what are these courses like? I don't really. So you sit around, and you haven't really invested too much of your time, and may not have paid your fees. Okay, because you don't want to get stung. But I mean, you can get your money back if you do it before the cutoff date. But if you pass that cutoff date, you can't get your money back. Okay. You're going to lose. And that's where, so you're kind of locked into the course. Now, if you switch to another course, you're thinking, I got to come up with another $500. That's a big cost to switch, and I'm not going to get a rebate back from the other one. But actually, the money probably isn't it matters a lot to me, but one of the things is the investment that you put into the courses, okay? You try and make a switch about midterm, April, to another course, because you think, there's no way I'm passing this one. I better try and pick up something else. You might have the money to pay that, but the amount of effort it takes for you to switch to another course and catch up in a short period of time, that's huge, right? And you imagine doing that just before the exam, like if they would let you, if you could do it before the exam, it would be almost impossible. It's very difficult in a week's study to catch up for 10 weeks' work. So you're kind of locked in, okay? And the idea of the lock-in is that to switch to something else is going to be very costly. Now, when we say when I say costly, and I think most economists, it doesn't just mean money costs. There are other costs, other personal effort costs, and things that you give up. Okay, and you got to worry about those kind of costs as well. We're going to put numbers down, but it's not always money things. These are heavy personal costs for being locked into a course. You're also locked into this university. Okay, you started out here. For you to move to Dunedin and go to Otago, once you've started, you got your flat all sort of set up and your things are established, and you're thinking, I hate it here, just for whatever reason. I want to go down with my friends down to Dunedin or go up to Auckland and get some half-decent weather, or, I don't know. It's probably worse up there. There's huge switching costs, okay? Now, those switching costs kind of make you locked into Canterbury, okay? I had a really sad case of a student who was locked into my health economics course. This was a few years back, and there's switching costs and there's switching costs, so this is phenomenal. So she was coming up to the end of the term and didn't want to write the exam. Came in and talked to me and said, there's no way I'm going to pass this. And I talked to her and asked her why. And, she really didn't understand the material. She hadn't putting a lot of time in. I said, why don't you drop the course? Okay, you're going to, instead of getting a fail grade, you get a withdrawal on your transcript. And she said, I can't do that. And I said, well, why not? You don't want it on your transcript. And she said, yeah, but if I do that, then I won't be a full-time student, and then my immigration status is going to be questioned, and I might be deported. Now, I think that's a huge switching cost. I mean, I was appalled, that a person would be afraid of dropping a course because they didn't want to get deported. I mean, that's like you're really locked in. You're really locked in that kind of situation. Okay, so the idea of lock-in is that you make some kind of investment, whether it's time or money, and it's a durable thing. It lasts over time, and then for you to change out of that to switch is going to be very, very costly. Now, so that's one example, just the switching universities. It's really interesting. It's so difficult for you guys. If you want to transfer up to Auckland or to Otago, it's a pain in the butt to get cross credits, right? People come from Lincoln, they've done some economics, and somebody in registry goes 2 points. What? All that stuff I did, it doesn't count for anything. If you're an immigrant, you come in from you're a professional nurse, professional doctor. It doesn't matter how much training you've had. You have to do it all over again. Okay, so to switch, it's really costly. Where was I going with this? God, my brain is not working today. Let me. I get away from my notes too much. Okay. I use a Mac, okay, and I've been using Macs for 15 years. I have a lot of Mac hardware. I have my computer. I have some external drives. I have some sound equipment that connects to it. I have lots of programs that work with the Mac. And if I was to switch to Windows or PC, I'd have to buy all of those programs new again, okay? And that's a big cost for me to switch. I use Mathematica a lot. It's a great program. Runs on. I could spend another it'd be about $500, I guess, to switch to PC on Mathematica. But I'd have to retrain on Mathematica in another system, okay? Or if I wanted to get away from Mathematica and work on MATLAB or Maple or these other mathematical programs, so much training to switching costs. So you've got these personal switching costs which can get very, very high. But this stuff that I do is quite important to me. I'm quite keen on this multimedia things, getting little video clips out for you guys because it's a factory, right? There's 150 people here. There's no personal attention, but I'm thinking, well, I can kind of improve things a little bit for you. So I've got this offshore website going. I got the college to help fund it. They got me a programmer, and so we wanted to put this stuff up that looks pretty cool. But you have to know all about database programming to do this. I don't know that, so we hire a guy to program. And I'm sitting there thinking, what if this guy goes? What's going to happen? If I needed to adapt it. So we took a system where it's possible to hire other programmers at $50 an hour to come in and make your adaptation. Okay, so it's expensive, to get locked into a particular programmer, to get locked in or tied into a particular program, and then you got all these formats. Like right now, Apple stuff is going hot because iTunes is really popular. Everybody's using the iTunes things. MP3 is a nice format, but the video formats are all over the place. I was thinking, have you guys ever actually seen a floppy disk? Okay. Well, the old floppy disks from the 1980s, you can't find anything that can read those things anymore. And I'm thinking, what happens if all the stuff that I'm doing in 10 years, who's going to be able to read it? What if it changes? I'm stuck with it. So if I try to switch to something else, it's going to be very expensive. Okay? So the idea of the switching costs is significant for personal things, for your courses, when you're buying computing sort of stuff. And there's a whole range of lock-in concepts, which how are we doing for time? Okay, let me. I'm going to introduce 6 concepts which are in Chapter 5 of Varian, and then we'll have I'll have to decide whether I'm going to come back to this or make it on a little video clip for you, because it's really just another sort of sequential game. But let's have a look at these ideas. The first way that you get lock-in is by have a contract, okay? And so, for example, you have a lease for your flat. You got to put down a down payment. You want to get out of your lease, you lose your deposit, okay? And so it's costly to switch when you've got contracts. The second type of sort of source of lock-in and switching is where you have these durable investments like a computer and software. And built around that software or that computer is lots of different software. There might be different programmers. You might be in a business. There's lots of other stuff that's kind of tied in with it. And so when you change one thing, you've got a whole system of stuff that you want to change. Okay? And it could be it's very difficult to change all those other parts, and that makes it these durable investments could make it costly. Now, Varian has a really nice example. He says, well, take your car, okay? It's a really complex thing, but you got a Holden, you got a Toyota, you got a Honda, you got a Mini or something like that. Well, you can switch cars. I mean, and you sell your old one and get a new one, and there's that transactions cost there, but it still fits in your garage. You can still put your trailer on it. You can take your kids along. All the skills you learn driving, they're all transferable. So even though something's complex and part of a system, it doesn't necessarily mean you're locked in. It's only when it's really specific to those things. It's like, wow, I got to make a lot of changes. It's going to be very costly. Okay. The second idea is the training that you get. Okay, when you're trying to, after you get some experience and stuff like that, like you decide you're going to be an engineer. You're going along doing being an engineer, and then you decide, I really want to go into fine arts. Okay, it's like it's like I have to retrain. Okay, so that retraining can be a big source of switching costs. Converting formats and portability of machines, like the Mac has really upped the ante on Windows these days, because now on my Mac I can run Windows operating system, and so I can use all that software. So it's really easy for me to switch to the little bits of PC stuff that I want to use. Before, they were totally separate, and this is a strategic choice that Apple made. They thought, whoa, you're really putting on the heat onto Microsoft, and they're the kind of guys you don't want to put heat on, because mind you had no idea in the mid-'80s. Microsoft was nothing, absolutely nothing. They had this crummy word processing program, Word. They had a lousy spreadsheet, Excel. Their WordPerfect was much better. Lotus 123 was much better spreadsheet. They were just, that application software didn't matter. What got them going was that IBM had given them these rights to the DOS operating system, and everybody used that. And then, so everybody was locked into Microsoft, and they took advantage of it. Okay. Since then, they've done all kinds of other things, but another source of lock-in is where you have a single supplier. At the university here, we have to get our air travel through Signature Travel, and they get some discounts, and it's quite good. They have terrible service, absolutely terrible service. But for us to switch, I'm thinking, what do I do? I go to another agent that I like and pay 10% more, or do I save the cash? But we're kind of locked into these guys. Okay. Search costs. To switch means you got to find out about other things, okay? You want to change to another university. Will it be better over there or not? Will they have good teachers or not? They got a good library or not? What's a computer lab? It's like, I got to find all these things out, and I'm not sure, and it's like, that cost of, that riskiness makes it, you're locked in because you're averse to risk. And the final source of lock-in is these loyalty programs. Like for the last 6 years, no, I guess about 10 years, I've flown on United a lot when they used to fly back and forth to see my family back home and do conference sort of stuff. And I got these frequent flyer programs. Like every 3 or 4 years, I'm getting a free trip to Europe or North America. This is cool, okay? If I switch, I don't get to carry those frequent flyer miles over to Qantas, okay? Qantas has some good deals, sometimes better deals than United has. Then they made the Star Alliance, which hooks Air Canada, United, Air New Zealand all together, and the transferability. Wow, that makes it a much greater thing to be, except then if I want to go outside the Star Alliance. So you see that the loyalty program stuff, and it's going to be really influential in the future. Every time you shop, people are going to be keeping records of what you do. They're going to give you your discounts. You're going to switch shops. It's like, it's a cost. Okay, now these are concepts which come out of Varian. They're absolutely fascinating. It's very easy reading. I think it will take 10 minutes at the beginning of the next class, though I do want to get into simultaneous games. We'll just draw a little game tree down here to try and get an idea of what's going on with these switching costs. How could another player take advantage of those? Okay? And they do. So see you next week.
This is just an add-on from what we did in Lecture 6. I want to take the idea of lock-in, which is related to the notion of switching costs, and hold up, which is related to the notion of other players take advantage of your switching costs, which helps them but costs you. Okay? And we're not going to look in too much detail here, but just to see how we can use game theory to structure our thinking about these things. Now, if you remember, we went through a whole list of various types of sources of lock-in and switching costs. Okay, you have contracts and durable goods purchases and follow-on products upgrades. You get specific training that you might have to change, and it'd be costly to change. You got codes and formats and software and all kinds of stuff that might have to be changed. You got specialized suppliers like your doctor or whatever. Then switching to other suppliers is going to be difficult or costly. Uncertainty with what you're going to find out, and just that cost of actually researching stuff. And then you got loyalty programs where where if you make a switch, then you're going to lose something. So all these sources of switching costs are kind of important, and definitely read Varian Shapiro, especially Chapter 5, to get a handle of those. Very interesting stuff, okay? But we want to look at the strategic issues here. Draw a little game tree. Okay. Now we're going to start out with the blue player. Where are we here? It's down here. The blue player is the supplier. The red player is the customer. The blue player is doing some stuff, okay? It makes some moves. And the red player, the buyer, gets to observe this stuff and basically doesn't like it, okay? Or thinks about the fact he doesn't like what's going on, and he's got a choice: either stay with his blue supplier or he can switch to the green supplier, okay? Now, if he stays with the blue supplier will do some more stuff, and can look at the benefits and costs to the red player. And the idea here is, instead of putting just a rank ordering of this, we're saying, what does the red player think about this? Well, there's some benefits that he gets out of being in this relationship with his supplier or using this technology, and there's some costs, okay? And you could think of the cost as the price that the blue guy will charge, and the benefit is some measure of the dollar benefit that the red player gets out of this whole process, okay? But let's suppose that the price is getting jacked up or the quality is going down, and you're thinking about switching to the green player. Well, if you switch to the green player, then the green player is going to do some stuff, and then you're going to get some payoffs. And the idea here is the structure of these payoffs are like you've got some benefits and you've got some costs. The costs here will be related to what the green supplier charges you. But you've got these extra costs, which if you switch, okay, from the blue guy to the green guy, you're either going to be giving up these loyalty things, you're either going to be having to undergo some search costs, you're either going to be having to pay out of some sort of contract, you're either got some extra other equipment you're going to have to change over and switch over, you've got to retrain, all kinds of things which might happen. That's what these switching costs are here for. Now, notice this is just a labeling system really for us to keep track of the choices. Okay? It's really just the choice of the red player, and I think it was one student said, well, wouldn't it just be benefits over costs? Well, it is, yeah. We have to kind of tease out what the benefits are and what the costs from blue, and what the benefits and what the costs are from green, what the switching costs are, and on balance you'd want to switch if you get more benefit here than you get over there. Okay? But it could also be that you might get some net look like just at the price and the benefits you get green look good, maybe even better than the price and the benefits you get from blue, but by the time you take into account the switching costs, it's not a very attractive thing to do. So you're locked in to staying with red, okay, because of these sources of switching costs. Now, let's just look at it from the perspective of the supplier now, okay? So we've got the situation we had before, but now we're putting in some payoffs to the blue player, the supplier. And the payoffs to the blue player are related to the cost to the red player. Okay, so think of this as like a price that is paid by the red player, and this is either the same price or after some deductions or additions, it's the price received by the blue player. Okay, so if the blue player kind of racks up his prices, then the red player is going to get smaller and smaller benefits. Okay, that's one idea, and that's why you might want to switch. Also, let's say the benefits you get are related to quality decisions the blue player makes. Well, the blue player could, by incurring extra costs, improve quality, and that's going to improve your benefit, but he doesn't really want to do that because extra costs to him mean less benefit for him, okay? So again, he might be running down quality, and that's why you're thinking of switching. The hold-up problem occurs because it costs you to switch, okay? Now, let's just say that the green player is about the same in terms of net benefits as the blue player, net benefits for the red player, okay? But slightly better, okay? And it's coming slightly better because the price is a bit lower, or it's slightly better because the quality is a bit higher. But to get over to that green player, you're going to have to pay these switching costs, and by the time you look at them, it's just too large. So you're locked in. And what happens, then you can think of, is the blue player has some choices here, you know. He can start to raise his prices or reduce his quality to keep it so you're just not willing to switch, okay? That is, he can hold you up and extract some value from you. And so that's really the strategic idea between the hold-up, relationship between the hold-up problem and the lock-in problem. Lock-in is created by my high switching costs, and the hold-up is when some other person can extract value from you because you're locked in, you're kind of held up. Okay. Now, you might want to try to modify this game, and we're not really going to look at changes in strategic situations until a bit later in the course. At least look at a whole summary of strategies you can have for a changing game. But one thing that Ferrier and Shapiro stress is, like, let's go back in time here, okay? So if this is the present, well, yesterday this was the future, and this was the present. So back here, before you're actually committed to staying with this blue supplier, okay, you could have gone green. Now this is before you're committed, okay? So you don't have any switching costs at this previous kind of stage back here. So if we take the example of writing say a contract for a lease or something like that, before you sign up for your lease and put down your deposit, you could switch to alternative places to rent. If before you actually end up buying your Mac or your PC and then get locked into that and all the software with it, you've got a choice of what computer to buy before you go and train up on skills for a specific job. You have an options to train for skills for other jobs. Before you've incurred these other costs that lock you in. So the idea is that to anticipate, look forward, and reason back to try to say, okay, I can't avoid getting locked in. That's just the nature of the game. But what I can do, if I go back one step here, is to try to negotiate something so my benefits are going to go up, or the prices I pay are going to go down, or the quality's going to go up something, which we call a sweetener. Okay, and we could draw some arrows and things in here to say, well, what I really try to do is do some bargaining or negotiating with the blue player at this stage about what my benefits and stuff are going to be here once I'm locked in, because I know once I'm locked in, this guy's going to take advantage of me. Okay, but he can't take advantage of me until I'm locked in. Okay, well, I know that's kind of rapid. We come back to this idea of modifying a particular game to change it to your advantage later on. We get into chapter 9. Cheers, John.